Good morning, everyone. I'm Antonio. Welcome to the first lesson for the Design 3D Technologies for Healthcare. Today, I will give you this lesson in Parametric Design. We're going to talk for 3 hours and a half about many stuff. And I hope it's going to be interesting for you as long as it was interesting for me preparing it for you. Actually, I'm going to be the most vanilla guy in this whole summer course, meaning that I'm going to give you a lesson that will not entirely center it into the world of healthcare, but you can adapt the same teachings in other fields. I'm quite sure that most of you already use many CADs or any kind of form of it for your work, for your studies or whatever. So perhaps I'm not going to teach you something new, but perhaps I can teach you some new approaches. And as well, I hope you, if you have something interesting to share, something interesting you want to talk about, or some specific insight, please share it with us. It's going to be appreciated. So first thing, I want to share with you a little bit of an agenda. Can you see my screen? Let me put it better. Okay. So this is going to be our agenda for today, an introduction right now. That's what we're doing. Then we're going to have the first part where we'll talking about parametric design fundamentals. This will be the more theoretical stuff, meaning that I'm going to expose you some concepts, some topics, talk about some theoretical background in this whole thing. Then we're going to have a 5-minute break. Second part, Fusion 360 Basics, which essentially is just a bit more deep than the introduction tutorial that we already sent you. I'm going to refresh your knowledge about these things. And yes, we're going to use Fusion 360, but the same kind of things are going to be useful also for other CADs, such as SolidWorks, Onshape, or whatever. Then we're going to have another 5-minute breaks, and then the last part, put parametric fusion with Fusion 360. This is going to be the core of the lesson. Meaning we're going to make some more sophisticated stuff. And that's it. And then we're going to get a final recap. Consider that at the end of every part, I would like to make a quick question and answer session, or if you want to show off something that you're doing in the meantime at home with your computers, or if you want to ask something, or if you want to, I don't know, yes, I've heard about that, but have you heard about this? Share it, totally fine. As I said at the beginning, I prefer you to vocally interrupt me at the end of these parts instead of any time, unless I said something really stupid and you want to interrupt me, please do so. It's totally fine. Otherwise, post everything on the Slack right there. I will look at it from time to time, and if there's something that is really urgent, I'm going to look at it. So let's start. So, my window. So, first of all, let me talk about OpenDot a little bit. For those of you that don't know it, OpenDot is a fab lab that is located in Milano. We are in Tertulliano zone, and is a beautiful place that is divided in two. We have the part that is called OpenDot, that is for the fab lab, and we have another part which is ... which is more devoted to interaction design, installations, museums, and so on. OpenDot was born 5-6 years ago, and since then we've grown a lot. We did many projects, and right now we are into many things. First of all, we are a place for making. People come here and do stuff. We use the typical machines of digital fabrication techniques, such as spinal cutter, laser cutter, milling, 3D printers, and so on. And the best results are from the adoption of all these technologies together in a wise way, meaning that we don't just print knickknacks. We don't just mill gadgets. We use our technologies in order to achieve something. And as well, we are a community hub, meaning we are a place where people can gather, people can come in, use the machines, ask for our opinions, and so on. Well, in this funny time of global pandemic, right now we are not so open because, there's this little thing called COVID-19 that's going on. But we really hope for opening soon. Alessandra, do we have news about it? Not yet?
Not yet.
Not yet.
But check our social and website.
Yeah, check them out. So yes, but soon, hopefully really soon. And this is also a place for research and prototyping, meaning that we are constantly looking for new solutions, new technologies, and new ways to achieve something that can be done with the tools at our disposal. which enables a really, really huge potential as long as we can use them. And hopefully courses like this will teach you how to make the best of the tools that you can find in Fab Labs, and also to understand how certain technologies can enable an individual, can enable a community, a society, and so on. And actually, as many of you surely have seen, the response of the maker community and the Fab Labs all around the world was amazing in the time of the COVID-19. And we believe in co-design, meaning that we build our stuff around real needs, around real people, and together with them. We try to understand what are the things that are going on, what are the needs, what are the requests, and develop a solution that is tailored for that need. Of course, then we are trying to adapt it to many other fields, to many other people, but every solution is kind of unique, and especially for the field of healthcare. We are really, really into healthcare, meaning that it's a field that we put a lot of effort. We do make a lot of research. We make a lot of effort into find solution, into find projects, into find people which we can collaborate with. And this is me. Yes, he looks like me. I'm Antonio, lab coordinator at OpenDot. What does it mean? Well, essentially means that I manage stuff, meaning I make orders, organize stuff, meet people, and get the manage stuff. So I look, I make so that things go on. I try to make them running, and if not, there's people like Alessandra and all my colleagues that get me back to reality. And yes, I make a lot of silly jokes as well, and that's part of my job. That was actually the reason they keep me in all the time. But beyond coordinating stuff, I also am a developer, meaning that most of the time I write code. In the background, you can see some projects. I mostly make web development and embedded programming. And this is really important, because if today I'm giving you this lesson in CAD design, it's because I have a foundation on programming. I'm going to talk more about it later, but these two things are related, not just in the field of CAD design, but essentially in the field of parametric CAD design. Those two things are totally related, and we're going to see why. And also, I'm an educator. Here, I make a lot of courses. I am an instructor for Fab Academy at OpenDot, and this year we have seven amazing students. And I do a lot of courses, and I do also some courses on Arduino. You know, we make these we made these Tuesday evening courses, and I used to hold the Arduino course. Hopefully, we're going to start them again soon. That's it for the presentation, and now let's start with the first part, meaning I'm going to talk about parametric design fundamentals. This is the first time for everyone. This is the first time we do this kind of things. Oh, yes. In this picture, you can see in the background, this is the summer course of the last year. There's a guy, Mattia, which participated to it. It was an amazing experience for him. And here, I think we are trying to solve, I don't know, word problems, existential dread. I don't remember what we were trying to resolve. But this was last year course. And this year, due to this, again, this little thing called COVID-19, we moved online with a different kind of format. So since it's the first time for everyone for this kind of thing, I'm not sure how I will behave, meaning if I'm going to rush or if I'm going to drag, in case I talk too fast, in case I talk too slow, just let me know. Let me know and I'll try to adapt to it. First part, parametric design fundamentals. I'm going to start with a very, very stupid question, with a very, very stupid answer, but I want this covered. I don't want you to assume anything else. And I know you already know that, but I really, really want to be sure about it. And the question is, what is design? For the lovers of false friends, especially for the Italians, designing is not about drawing, but you already know that. If you don't know that, you know that now. And in my opinion, and my opinion might not worth a lot, but I sort of dig through these kind of things all day long. Design is about choices, meaning about wise choices that you make regarding to find a solution to a specific problems. When you have many choices, when you have many things you have to figure out, then you have a project. So I think that at that point, designing is about projects. But projects themselves are a part of a process, are part of an iteration. And so in the end, I really believe that design is nothing more about design methodologies. You already know that there are many design methodologies around the world, like design thinking and so on, waterfall thinking, spiral prototyping, and so on. I really believe that prototyping is nothing more than those things applied to certain fields, like, I don't know, graphic design, web development, video game development, or whatever. The image you see below, it's a design thinking process. I'm quite sure most of you know that. Keep in mind this thing, because even if we talk about CAD design, meaning using a software, we're really talking about a process of a project, a part of a project. And it's really important to have that thing in mind. We are not just making a fancy drawing on the screen. There is Microsoft Paint for that. What is computer-aided design? Well, a CAD is anything designed with a computer, with any software. And I really mean it, meaning that there are a lot of people that do CAD drawings with any kind of software, be it old, be it new, be it sophisticated, be it simple. But as long as you have a projectual purpose around your design, then you're using a CAD. It's nothing more. There's people actually doing projects with Microsoft Paint, and there's people actually doing fancy art with SolidWorks. So it's totally fine, as long as if you have a purpose. Remember that a software is nothing more than a software. It's your intention that make it useful or not. But for the purpose of CAD design, of CAD softwares, what we really want to achieve, what the history wanted to achieve, is to overcoming blueprints, meaning those fancy drawings, really cool to see, really inspiring in many ways, but difficult to replicate, especially for the average Joe around, meaning that if you are a normal guy and you want to replicate something, unless you have really specific knowledges about blueprints, technical drawings, and so on, it can be difficult to adapt them to a real project. It can be difficult to adapt it to something intentional, something that you can make a project out of it. CAD really simplified the process, meaning that you can open a file all around the world and it will always behave the same. Today, we're going to talk about a major difference regarding direct and parametric design. Well, what are the differences beyond the two? In parametric design, you use measures, meaning that you create measures and relationships between projects, between objects, in order to make them adapt to a specific project, to a specific geometry that you want to adhere to, and it requires careful planning. Meaning that if you want to make any non-trivial object, it will require a lot of attention, a lot of patience, a lot of dedication to every single detail that you don't want to overlook. Instead, direct modeling can give you a bit more freedom, can be more straightforward, because essentially you sculpt the thing, you model them out of crude matter. You can see here I made a cube. This is Fusion 360. I made a cube with a parametric approach and a cube with a sculpted modeling approach. And yes, those are not refined at all. But the point is that in the cube above, I could sculpt it. In the cube below, I could calculate it. That is the major difference. And even this might seem that direct modeling is more for artistical reasons. That's not true. Actually, many designers, many engineers adopt direct modeling all the time because they can give them more degrees of freedom. But at the same time, there are certain pros and cons in both of approaches, which are totally fine. Remember that most of modern cards around the world have a blend of both tools, meaning hardly you will find a professional CAD software that will not let you make some parameterization or some sculpting and so on, unless you use really specific softwares, such as OpenSCAD. It's a famous parametric modeler, but it's only parametric because you can't model out of it. You essentially write lines of code in order to make geometries. So you can't move your mouse around and sculpt something. And that's it. Direct versus parametric design. Well, the first requirement for parametric CAD is the possibility to set up measures with a parameter. Sorry, I have a bit of a sore throat, so if I stutter, I will repeat myself. So yes, essentially you set up measures and set up relations with them. As you can see in this image, I set up a square and then a circle being tangent to it, and at the same time touching the midpoint of the lower side. So this simple requirement, this simple assumption can already give you a great potential, can already enable you a lot of things that you can achieve, as long as you treat them with detail and carefulness. When things get complicated, you get to formulas and algorithms. In this clip, in this screenshot, you can see a Grasshopper program. Grasshopper is a famous plugin for Rhinoceros, and it's kind of famous because it allows you to make really sophisticated stuff without actually writing line of codes, but just by joining nodes together. And you can make really cool stuff. Essentially, a node is nothing more than a part of a formula. And in this way, you can make out of simple shapes like a cylinder or a flat shape like a square and so on, really non-trivial objects. As I write in here, it requires a much more polymath-oriented approach, meaning that when you get to algorithms and formulas and more sophisticated stuff, unless you know what you're doing, it's hardly you will get a really meaningful result, something that can be adapted to a real project. Because if you don't know how an algorithm works, if you don't know how 3D geometry works and so on, it's going to be really difficult to adapt your vision to your project. And so yes, it requires a bit more knowledge about many things. We'll talk more about it later, also about this. Reasons for parametric design. First of all, customization. You can adapt a parameter to whatever you want. There are central rules you can set up, and then you have different models, but with the same geometry, just changing a parameter. In this screenshot, you can see a Vetturi valve that was made by a user in GrabCAD. GrabCAD is this famous website where engineers all around the world collect their stuff. This guy made this Vetturi valve. A Vetturi valve is a valve that mixes oxygens and air in order to be breathed by people in the hospitals, by patients in the hospitals with respirators. And the different valves in here allow for different mixing regarding oxygen and air. So you just changed a couple of parameters and you obtained the different models. And this is a really cool feature, meaning you get to have potentially infinite combinations out of just few parameters. Non-trivial relationships. What does it mean? That it's not just like here what the designer changed was nothing more, I think, about the height and perhaps the inner diameter of the glass tower-like shape. In here, this is a famous building in Bilbao. It's the Guggenheim Museum in Bilbao, made by Frank Gehry. I don't know if any of you have ever been to Bilbao. I've been there once, and by chance, I stumbled upon this building. I was like, wow, what is this thing in here in front of me? Yes, I'm kind of an AV guy. I went to Bilbao not even knowing that there was this building in there. And this is one of the first buildings that used a fully parametric CAD approach, meaning that Frank Gehry, which actually personally is not really good with computers. He has, I don't know, 500 interns that turn off the computer for him, but he had a vision that he couldn't translate, and he couldn't translate with his subcontractors. He had to show them something, but didn't know how to do that. So he envisioned a different approach with the CAD softwares and modeled this amazing building that couldn't be achieved with the standard workflows. He totally had to use CAD and totally had to use parametric CAD because all these shapes kind of relates to each other in a specific way. And it's not just about buildings, it's just even about objects. Perhaps you have a sine wave that you want to apply to your product, to your object, and hand drawing a sine wave can be really difficult. Instead, for a parametric CAD software, it's nothing more than writing a sin, parenthesis, x, close parenthesis. It's really simple to make non-trivial relationships and objects out of few keystrokes, which is really, really cool. And projectual flexibility. What I mean with projectual flexibility, well, what you can see in here is another design methodology. It's called the spiral prototyping. I'm really, really sure most of you know what that is. Meaning that when you're into a project, you don't just stop at the first result. You don't just stop at the first prototype, but you spiral, you go on and on, every time refining your project, every time fine-tuning what are the details, what are the requirements, and so on and so on and so on. This is actually kind of a standard now in design studios and even in Fab Lab like ours, meaning that we prototype a lot, we make a lot of mistakes in order to get as soon as possible to the final results. And projectual flexibility is nothing more than that. Projectual flexibility allows you to make adjustments along the way. If I made a project with a parametric view, I can easily adapt it to my new refinements. I can easily fine-tune it to my new specification, my new requirements, and so on. And this is really useful because instead, if you have to sculpt it from scratch every single time, you're going to use a lot of time. Time means people involved. People involved means money, and so on. So you're going to waste a lot of money, time, resources, and so on, just because you preferred using your mouse instead of using a formula. Nothing more than that. But actually, it's not that. I don't want to scare any of you, meaning that parametric design doesn't have to be formulas and algorithms and matrix and whatever. It can be just setting at the side of a square. Nothing more than that. But with a purpose, with a reason behind it. And if you keep track of that reason behind that side, then you can easily adapt it. I'm going to talk about it later. It's going to be a funny thing to say later. There are reasons against parametric design. Why not? There surely can be against. First of all, you cannot make organic complex shapes quite easily with parametric design. For example, in here you can see a 3D model of a reconstruction of, I think, of a guy that had a massive headache or something like that. And it's really impossible to, no, it's not impossible, it's really difficult to make it even approximately just like that with a parametric approach. Instead, you make a scan of that person, then you reconstruct the object with the specific software, and then you adapt the mesh in certain ways. And actually, you're going to see that with Alberto's lesson. Sorry. But remember that sometimes if you have to achieve a really complex, a really organic shape, parametric perhaps is not just a good approach for you. Just that. No digital fabrication at all. That is something, well, it's kind of stupid, but also sophisticated to say. What you see here, this is a screenshot of Japanese wood joints. You know that in Japan, they have this strong culture on woodworking, and they have also a strong culture on woodworking without using nails, screws, and stuff like that. So they developed a really huge amount of joints made out of wood that you can make with just tools, with simple tools. It requires a lot of care, a lot of skill and so on, but results can be amazing. The point is, most of these things are not totally suitable for digital fabrication because you can't easily, I don't know, mill a shape like this. Mill shapes like this with a simple 3-axis CNC. So it's better to not use digital fabrication tools, but go with that then with your hand, with a chisel, with a jigsaw, whatever you have, and do it in a different way. Funny thing is that making CAD drawings of Japanese wood joints, it's a good exercise for making practice with a CAD software. But rarely you will do that with a parametric approach. So there's a purpose of it for in the world of CAD, but there's not a real purpose of it in the world of parametric CAD. And I really believe that if you don't really have to use a a digital fabrication technique in order to achieve your design, then perhaps you don't really need parametric design. But perhaps it's just my opinion. I'm available to be challenged if you want to. Another reason against parametric design is uncertainty of design. There's a typo. Uncertainty of design. What does it mean? In here, perhaps you don't see it really well, but this is something that I was drawing yesterday, and I made a huge mess in here, and it reflected also in here, just because I didn't set up properly certain constraints, certain measures, and so on, because I had no clear view about what I was doing. So not having a clear view, not having a clear design made me waste my time. I had to throw it all and start from scratch, but this time with a more systematic approach and with a better understanding of what was going on. What I'm saying, if you have to make complex objects and sophisticated projects around a parametric approach, but you're not sure about what is going to be, perhaps not starting with a direct parametric design approach, it's not a good approach. It's not the best way to start. Instead, perhaps you have to understand better what's going on, what you really want to achieve, and if this kind of approach is good for you or not. So keep that in mind whenever you have to, when you have to draw, to design these kind of things. We're going to see this image later because actually we're going to work with that. Applications for parametric CAD. Production requirements. Well, there are many things in fabrication that can change according to the machines you're going to use, the kind of material you're going to use, what kind of adjustment you have to make to, in order to make them apt to your project. So having, I don't know, a parameter for the offset, a parameter, I don't know, this is a famous Warhammer model for role playing, I guess. And you can see these are the runners for the mold injection fabrication. Well, these runners have this size for a reason, because they use that material, because they use that machine, and so on and so on. Perhaps if they use a different approach, a different machine, they have to make these runners of a different diameter, width, or whatever. And having to redraw that from scratch can be painful. So instead of using an offset or I don't know, a diameter parameter to set up that value could be a huge time saver. And a time saver is less frustration and better productivity and better satisfaction around your project. So yes, production requirements are an important part of the world of parametric design. For example, if you're going to 3D print something, it can change drastically if you're going to print it with a FDM machine or an SLS machine, because they use two totally different printing techniques. So perhaps the support will have to be totally different, and so on. These are all things that you can take into account when you're making parametric design, and you should do that. That's the point. Functional customization. What I mean with functional customization, you can see in this picture in here, this is Alberto. He is our golden boy from the lab. He's also our digital fabrication expert. And in here, he made this bicycle for Shaig, this little girl. We have this project called the Bike for Everyone. And these bikes have to be fine-tuned according to the specific needs of the user. Shaig had a specific length of her back, a specific length for her arms, or position for her hands, and so on. So Alberto had to adjust his parametric design according to Shaig's bio parameters. And that's an important part, because user-based requirements are essential in the world of accessibility, universal design, and so on. When you know accessibility is in general considered one of the best field for investigating into parametric design, because there are not two people the same, but everyone is kind of alike to each other. So having an approach that can make you change your parameters according to specific finger length or I don't know, radius of the head, and so on, will give you a lot. Will make you save time and give you will make you do better projects. Assembly constraints, what I mean with that, regarding functional customization, assembly constraints meaning that if you have to join two objects that are not part perhaps of the same design, but you're adapting this kind of wheel to this design, and perhaps the supplier of this wheel, went out of business, then you have to find new wheels with a different truss or rod diameter, then you have to change your design. If it was made, you already know what I'm going to say. If you're going to use a parametric CAD, it's going to be much easier for many reasons. What else? Aesthetic customization, and this is also an important part. I'm going to talk about it in two ways: systemic harmony and user-based preferences. Systemic harmony, what I mean with that, that more often than not, people are good looking if they respect certain relations. There are this stuff like the golden ratios, the pi number, and so on. All these kind of things can be useful in making your project not more functional, but sometimes even more functional, especially for the golden ratio, but generally better good looking. And have a good looking project, have a good looking product. It's totally better than have an awful looking product. So yes, systemic harmony can be nothing more. There is Luca, Hemalus, Ameti. Okay. Welcome, Luca. So having systemic harmony can be a good thing, perhaps just for the eye, just for the appreciation of it, but it can change a lot. It's the reason why many people buy iPhone and MacBooks instead of Asus and so on. And I'm not going to say that one is better, one is worse. Essentially, they ring something in you just because they respect some kind of rules inside of you. It's the reason why flowers are so beautiful and so on. User-based preferences, it's nothing more than aesthetic customization. In this picture in here, you can see this guy. This is a guy with an amputee guy without a limb. And he 3D printed an hand based on the video game Deus Ex, which is a video game based on body modifications. And yes, it kind of faked the identity of it, meaning it looks like it's made out of carbon fiber and gold and whatever. And it's nothing functional, it's just fancy. But it can be really helpful for the user, especially if the user has to use it every day. Amputees are a good example because sometimes you get when you use standard default limbs, standard default prosthetics, you get that strange effect called the uncanny valley, which can feel awkward, especially for the user. Sometimes prosthetics are too surgical, too cold, not really good looking. Something that looks out of an hospital, looks like it's out of a factory and nothing more. And sometimes they have this Bowden on them or made of silicone that is pinkish, but can be soiled quite easily, so it becomes pinkish grayish over time, and so on. And it can be awkward because it totally entices the phenomenon of the uncanny valley. Instead, having an amazing robotic arm, you don't care about anyone. Yeah, I have a robotic arm, I don't care about you. It can be much better for the user. So respecting the user request and adapting our parametric CAD according to the user request can be a win-win solution for everyone. Win-win solution is kind of repetitive. So yes, I want to focus just a bit more on prosthetics, because prosthetics, it's also that kind of thing that's really complicated for many reasons. There are not two amputees in the same way. I mean, when someone is missing a leg or an arm or something like that, it's because of a genetic default or genetic flaw or for an accident. And those are not things that are made out of a butcher shop. Most of the time they are amputees, they are disabled people, so they have a piece of limb, they perhaps have an extra finger or whatever, they can be remained out of the limb and so on. So not having two same people made over the years made the prosthetic field the place where only sort of artisans worked in there, because there were technicians, artisans, as I said, that could make that are making prosthetics out of lengthy operations, lengthy techniques. Have to make a cast of your arm or your leg, then adapt it to a model, then use chalk, and so on and so on. Digital fabrication kind of revolutionized it, not in terms of robustness of the results or robustness of the products, but more in the lightness of the materials, on the user-based preferences, and so on. So there are also a couple of really, really good projects around there that are making, easy customizable prosthetic limbs with, I don't know, chassis so that you can remove from them, so that you can change the colors, you can change the materials, the appearance, and so on. And yes, I'm just saying that because it's actually a really, really field of approach. Some historical precedents. The Vitruvian Man by Leonardo da Vinci. Why I'm showing this? Because there is nothing new under the sun. People try to look for relationships and parameters since centuries. And you know, the Vitruvian Man by Leonardo da Vinci is nothing more than that example. It's a man that is inscribed inside a circle, which is inside a square, and so on and so on. And all the things are part of relationships, meaning that the head is 1/8 of the whole body, the finger are a certain ratio of the whole arm, and so on and so on and so on. You can see this as a ante litteram approach to parametric drawing, because Leonardo da Vinci got inspired by this architect Vitruvio to draw this model, to have a sort of cheat sheet to look at whenever he wanted to make a new body drawing. Okay, I have to respect certain parameters. Let me look at my cheat sheet, my Vitruvian Man, and so on. And this is it. Actually, recently it has been speculated that there's also another layer of reading, which is that it's actually the head is divided in two, meaning one side is a person that is old and one side is one person that is young, so with different parameters, so to say. And it's really, really interesting to see that designers of all times, and one of the best designers of the ancient times, also was looking for a way to adapt his visions, to adapt his designs to many situations, especially in this case regarding drawings. Modular by Le Corbusier. Le Corbusier was a famous architect, but which was more artistic. And when he made the modular, it kind of followed the same approach of Leonardo da Vinci, but with less unsolicited dick pics, of course. And the point is, the modular was to see the standard, was to define the man as a parameter and see how buildings, shapes, and streets and furniture and so on could be adapted to the surrounding. It was an interesting project. It was a really sort of a vision that made him famous, of course. But the point is that it's kind of related more to artistical visions than to technical visions. Because Le Corbusier, yes, was an highly technical architect, but he was also kind of a artsy. So modular is an amazing example, but it has a lot of heart and fanciness around it. So it's not just technical. Instead, if you want to look at something really technical, you should look at Human Scale by the Harry Dreyfus Associates. This is an amazing project, and I can't stress this enough. This is a project from the 70s, which was reprinted recently as part of a Kickstarter campaign. And it cost a lot of money, but it's amazing. I really suggest if it ever comes to your hand, look at it, copy it, study it, because it's an amazing example. What this architect firm did was to make 9 tables with parameters, nothing more. They made images over them. There you can see there are these little white squares, and in these squares you can see there are numbers. Whenever you rolled this wheel on the side, all the numbers would change at the same time. So if you wanted to see, for example, this is the dimensions of a man, you want to see how a young man, an old man, an average, a woman, and so on, you could just change the rotation of the wheel, put it to, yes, old man, and you can see the average height, the average width of the shoulder, the arm's length, and so on, and so on, and so on. There are 9 tables of that, and each one of them is amazing. Each one of them is has an incredible amount of informations that might be outdated for certain things, especially regarding it's not just about human relationships. It's also about office spaces. It's also about street patterns. It's also about monitors and so on, wheelchairs and so on. So for certain things might be kind of outdated, but it's still an amazing example, and I really can't stress this enough. Go Google for it, whatever you want. I actually want to get one to the lab because I have one at home, so I want to use it as a common reference for everyone. And it might not be used as a final reference for your project, but it's an amazing starting point. And it's a really inspiring in many ways. So yes, I totally recommend the Human Scale. And if you have a few bucks in your wallet, buy one because it's an amazing project. What else? Some contemporary examples. Parametric products. Well, we don't live yet in a world of many parametric products, but we are getting there. What I'm seeing here, what I'm showing you here, it's a screenshot from a website of another architect firm. And they used another important architectural project called Autoprogettazione by Enzo Mari, which in the 70s made this book about how to make the stuff by yourself according to certain conditions. So you wanted a table, you can use this blueprint. You wanted a chair, you can use this blueprint, and so on and so on. This architect firm, Filzen and Rohrbacher, they adapted it to an application, to an application you can install in your phone, and essentially you can make your products according to certain parameters. And it's a really cool project, especially because Autoprogettazione was kind of, yes, Enzo Mari, it's a strange figure in the world of architects and designers, but it was controversial, but it was right on many things. And Autoprogettazione was that kind of project that was really forward for its time and kind of foresaw all the things that later became the Fab Labs. So look for it. Parametric buildings. You can see in here a geodesic dome. They were invented by Richard Buckminster Fuller, the famous architect. And as of today, if you want to build a geodesic dome, you don't do that by hand. You don't draw every single triangle over it, but you set it on a software for parametric buildings. And the geodesic dome, it's kind of peculiar and kind of relevant in this field because it's enticing for its geometry. It's not enticing for its I don't know. It's actually a really robust construction, but it's something that is good to see, something to look at. But it's made out just of geometry. It's not made out of artistical visions and so on. So buildings made out of parameters can be a cool thing to see as well. Not just Baroque buildings or whole-time churches or whatever. One last example are online configurators. We are seeing an explosion of online configurators, meaning that right now, many websites are offering their online configurators for any kind of product. If you ever use the website Thingiverse, there's a web online configurator even for if you can upload your OpenSCAD project and you can set up an online configurator on their website. This is an example I'm showing you. It's about a recently delivered project about modular beehives, meaning that this website you can build your own beehive. You can stack up layers of different modules and so on and so on and so on. And this is an online configurator. There are online configurators for mostly anything, and actually we at OpenDot are also going to make an online configurator for one of our projects soon. So yes, they are kind of a big deal now, and it's not by chance. Meaning that in the last 10 years, there's been a huge explosion in digital fabrication and fab labs and so on and so on and so on. So people doesn't want to just make a standard project. They don't want to just print the usual project. They want to make customized project. So I don't see it a coincidence. There's a reason why online configurators are exploding right now. And the reason is because 3D printers are becoming more common. It's because using a CNC machine is getting easier and easier every year, and so on. So yes, look at online configurators because they are really, really cool. Okay, so let me see if you have posted any questions on Slack, or if you want to interrupt me regarding anything, do that. I can say, good morning, quick question. Is there an agenda of the course? Yes, I saw, I wrote that at the beginning, so this one was easy. Let's see if there's anything else. If any of you want to talk or say anything, do that. A project on a human scale. It's called Human Scale by Henry Dreyfus Institute. It's this one. Henry Dreyfus Associates. Henry Dreyfus was this famous engineer from the beginning of the 20th century, and now their firm are doing really cool stuff. Okay, so this was the introduction. I think I was kind of fast, but it's fine. And you share more info on the Beehive? Of course, Vale. I'm going to look at the link and post it. Just a second. Here it is. It's called Be Home. And it's kind of cool. Well, I think it's more fancy than useful, meaning that, yes, it's fine. It's amazing. But I think it's a lot of wood just for a beehive. It's more like, it's like when you have, I don't know, like dog or cat food that has flavor that people like, that the owners like, not the cat or the food like. So I think this is a fancy house, more for the humans than the bees, but it's fine. I guess it's an amazing project. I'm not talking bad about them. So let's talk now, next part, Fusion 360 basics. As I said, I will talk more about the topics that were about the introduction video, but it's fine because there's nothing bad in refreshing your knowledge about certain things. You might understand something more about my workflow. I might understand something more about your workflows if you want to share them, which are totally fine. And we're going to explore in detail certain commands of Fusion 360. We're going to see how it behaves in certain conditions and why it's made like that. I think, well, why it's not working. Okay. Why Fusion 360? I know that it's not kind of a standard software to teach taught at the universities or in courses or something like that, because it's relatively new. But it's still an amazing software made by the guy from Autodesk, and it was born out of it's kind of a devouring cannibalistic project, meaning that they are taking into it many softwares, many applications, trying to shove everything into in a single environment, which is something cool at the same time kind of strange, because you might run in the risk of getting a technology legacy, meaning that you're going to use if you just use a single software for everything, if that software goes discontinued, it changes too much or get a different pricing or whatever, then you might have problems. But beyond that, as of now, Fusion 360, I personally consider it a really amazing software, especially for the balance between designer and engineer-oriented approach. What does it mean? If you look at stuff like SolidWorks or CATIA and all the softwares made by the Soul system, they are totally made for engineers. And I say that in the worst way possible, because engineers have no fantasy, have no imagination, so they just stick to whatever is their workflow. And in my opinion, perhaps I'm not the best, I'm not the most entitled person to talk about it, but I really think that the workflow of Fusion of SolidWorks is too granitic. It's too cumbersome. Instead, Fusion 360, I think it really flourishes in this sweet spot where there are designers that have passed their years studying AutoCAD or Rhino or whatever. They want to make something more sophisticated, something more technical, and they get to Fusion 360, and it's amazing. Meaning that they are able to put their imagination into a more technical approach. And I really hope that engineers will take their technical approach and use the imagination that Fusion 360 can enable to them. At the same time, Fusion 360 has many things inside of it. It has a CAD, a CAM, an ECAD, a KI, and a rendering environment. What are those things? What are all those things meaning? Well, CAD, you already know that. It's computer-aided design. It's something that you draw on a computer that you're going to use later for your project. CAM is computer-aided machining. And this means that inside of Fusion 360, there's a simplified version of another Autodesk software called Inventor, which allows you to make machining paths of your project. You can create the full path for your CNC machine inside of Fusion 360. You can make the 3D printing G-code inside Fusion 360 and so on. And this is amazing because you have really have everything inside. The fabrication experts inside OpenDot, they kind of use Fusion 360 for all the time for this reason, because they don't have to skip between too many softwares with different dependencies, with different the standards and so on. But they can do everything in the same spot. And it doesn't mean that it will output a proprietary format or anything. You can output a toolpath that can be any G-code or can be used with a shopbot or a roll and mill or whatever. ECAD means electronic computer-aided design, because recently Autodesk bought another important software called Eagle. I'm going to show a screenshot of it. Just a second. Eagle, let's see if it takes the bird or if it takes the software. It takes the bird, but no, also takes the software. And the software that is useful for making PCBs. And why is this so useful? Because if any one of you ever delved into electronics, if you ever touched this topic, you know how ECADs are a totally different set of CADs, because they have different approach, different workflows, and totally different way of envisioning your project. What they did with Fusion 360 is to embody all the workflow, all the standard workflow of Eagle, and put it inside their CAD. Eagle was kind of the standard of the state of the art of it. No, it's not the state of the art. There are software that are much more sophisticated, but it's the most used for sure. And now everything is inside in Fusion 360. This means that you can draw your PCB board with all the components and simulate it and whatever you want. And then you can insert your PCB inside your project. So if I'm drawing a computer, I have my PCB that I've drawn on Eagle, then I can include it inside Fusion 360 quite easily just with the snap of the fingers. It's really amazing. CAE, Computer-Aided Engineering. Fusion 360 also has nice simulation features for stress lifts, flows, whatever. And they're really useful for people that want to simulate certain physical behaviors of their project. I'm going to say that it's not as sophisticated as other softwares are. Andrea Rabaldi vuole partecipare. Just a second, guys. I'm going to say that it's not as sophisticated as many other softwares. For example, I'm kind of sure that SolidWorks is much better on this topic. But it still has some nice features, and why not? If you have to use that, why not? And the rendering environment. Inside Fusion 360, you have the simplified equivalent of 3D Studio Max or software like that, and you can make the rendering inside them quite easily. Also, Fusion has cloud capabilities. And I know many people, many designers, many engineers don't see cloud software as something that's useful. But I have to admit that the trend is changing, and having a software, for example, I've drawn my stuff that you're going to see later on my laptop in here. And then when I made the login inside this other computer I'm using for streaming, I had all my projects in there. And so Fusion 360 is not like this other software I'm going to show you. It's not like this other software called Onshape, which I really admire because it's a really amazing CAD software. But it's just browser-based, meaning you can only log in online. You can see the projects online and nothing more. It's really amazing. It works really, really well. It was made by the same guy behind SolidWorks, so it's really, really, really getting a lot of, I would say, well, it's one of the most progressive, more advanced CAD around. But still, you can get only online. Instead, with Fusion 360, you can do your stuff on your computer using the calculation capabilities of your computer, and store everything online. Or you can use the cloud capabilities for rendering the stuff online and then store them on your computer. So there are, as of now, it's using most of the pros of cloud capabilities and few of the cons. So I'm going to say these are all reasons why Fusion 360 is a cool software. Now we're going to start making something on Fusion 360. I want to cover the key concepts, so understanding better the environment. So I'm going to stroll around. It might be boring for those of you that already know the software or already knows very well similar softwares, but we have to start from the ground. So let's do that. Okay, I want to talk first of all about the key concepts of the environment. So the data panel, the workplaces, the browser, view controls, and feature history. Let's see what them all means. This is my glyph. I'm going to start a new project. Here it is. This is Fusion 360. Whenever you start, you get in front of yourself the workplace ready to be used. This icon above in here, it's the data panel. In here, it's where you manage all your projects, and you can see all the stuff you're working on. And you can see all your cloud projects. If you're part of the team, you can see all the things. And you can get also quite easily to the libraries, to the samples, to the tutorials, and so on. You can also import stuff in here, meaning that if you're inside your project, for example, I'm here in Summer School, you can upload STLs, rasters, SVGs, DXFs, whatever you want. Then we have this part, which is the workspace, sorry. Workspaces are the way that Fusion 360 embodies different software inside the same environment. As I told you in the introduction video, we are going to mostly use the design workspace, but we're going to see a little bit of all the others as well, just because just to see the capabilities. We have the toolbar in here, where we have mostly all the tools for Fusion 360. And this is the other important part, the browser. The browser is where all the features are stored, and not just the shapes, the bodies, the 3D objects, but also, yes, the origins, the directions, the views, if you have different views, and so on. And you can quickly recall everything from here, and it's really, really useful when you have large projects and you need a place to store everything clearly and quite easily. The view cube, kind of easy, really quite easy to use, meaning it's just a cube that you can drag around to move your environment. And there are also the key points that you can use to get around. Oh, sorry. This is not my laptop, and when I use the scroll wheel, it's the opposite of mine. I get mad every time. Control on the bottom. These are really useful if you have to orbit around, move around, and you need the controls at ends reach. I suggest you to, if you want to get more into Fusion 360, I really, really suggest you to inspect them all, more than looking at all these tools, meaning with experience and with time, you look at them, but you only get your imprinting with these tools at the first time you use them. So use them as soon as possible to understand the capabilities. These are also stuff like, yes, multiple views or different layouts and so on. There's also this part, the display settings, which already gives some renderings capabilities. Let's see a simple example. This is our square. Cool. If I want, I can see it in a wireframe style. It's really easy, really easy to find, and so on. You can have many settings, and so on, and so on, and so on. You can set the shadows, and etc. I'm not going to talk too much about them because I really want you to explore them in order to have your own imprinting, your own way to see that. This is how I want it. Okay. Yes, another cool feature is this way of sorting stuff. I'm going to show you how it works. You can select by dragging in two different ways. What it means, you can move from left to right. Sorry. You can move, come on. You can move from left to right or from right to left. Right to left means that anything that you include partially will be included in your selection. From left to right, only those that are fully included. Okay, now I fully included just this face and it's going to select it. And it's not really useful in these simple situations, but when you get complex situations, complex projects, or I don't know, strange meshes and so on, it's going to be life-saving in many ways. Then we have the feature history. This is the part that is the most professional, the most useful in many ways. This is where you will be stored all of your progress, all of your advancements, meaning every time you make an operation, it will be marked in here. And you can travel through all the features back and forth in order to change them, to edit them, to update them, to inspect them, and so on. And once you make a change, everything will update in the timeline. We'll see that better later, but keep in mind because this is a really useful tool. Also, there's a way to disable this in case you don't want to use it because you don't want to keep track of a feature history for a moment. There is this wheel in here. If you click do not capture design history, it will not save the design history as long as it's selected. And that's it. Okay, let's see something else. More key concepts: features, construction panels, sketches, bodies, and components. Everything inside Fusion is a feature, meaning everything is a characteristic, a geometric shape, an operation. Sorry. It's some kind of, every geometry, every operation, everything is a feature. And features are, yes, the lowest level of operationability, of making operations on Fusions. Construction panels are the ways you do sketches over them, meaning there are standards, are these three-dimensional sketch panels. So construction panels, this one on the ground, the one on this side, and the other side. But you can make more by yourself. We're going to see why. Sketches are the 2D geometries. You sketch over a construction panel, and sketches are composed of features. A square is a
Antonio, you're muted.
Sorry, has it been for a long time?
Half a minute.
Half a minute, amazing. Okay, so let's get back to quickly. Construction panels are where you're going to draw sketches. Sketches are the way you make two geometrical features. Bodies are nothing more than the sketches made three-dimensionals. And components are the way you handle bodies for more sophisticated operations. Components are the highest level of abstraction inside the Fusion 360. A component contains usually a body, at least a body, and certain directions, origins, and so on. A component has its own geometry inside itself. This is an important concept. Let's sketch a few of them. So, start with making a sketch. You can see these are the three standard construction panels. Each one of them has two axes, the y-axis, xz, yz, and so on. I'm going to start to seduce this one. And these are all the geometrical shapes you can make inside Fusion 360. This needs to be explored, meaning that it hardly you will understand all of them in a single touch, not the first time for sure, meaning that you can understand them only by using them, only by making projects, only by adapting them to your project, to your requirements, and so on. I suggest you to make as many 3D designs as possible in order to understand them, and don't stick always to the same tools. Why? Well, what I'm saying is essentially you can see this long list of tools. All of them are nothing more than simple lines according to certain geometrical rules and certain constraints. So there are many ways to do anything. Explore all of them. Don't just stick to 2-point rectangles. If you're going to make just two points rectangle, you're just going to start from a point and to the other. Instead, there are many other ways to make rectangles, even from center and so on. And they can be much more useful according to your project. I also suggest you something really important, that it's valid for anything in life regarding computers, but also regarding CAD softwares. Use your keyboards as most as possible. What does it mean? That as of right now, during this presentation, I'm using a lot of the mouse just because I want you to see the movements that I do, the options that I choose, and so on. But normally I use the mouse much less, and instead I use the hotkeys. For example, if I want to draw something, if I want to draw a center point arc, I don't go to create arc and then center point arc. But instead I would press S and then write down arc, and then find it from here. Why that? Because of time. Because two reasons. First of all, time. When you do a project, you're going to make several hundreds, if not several thousands clicks. Each click will require you a movement, a naming, and then the click itself. And then perhaps you misplace the click, and so on, and so on, and so on. So you repeat. All these passages can be saved by a few keystrokes. And even if you save, I don't know, like 0.2 seconds out of every operation, if you multiply that by every single click that you make, you're going to save minutes, if not hours, for your projects. And the other reason is, well, and that means time, that means less frustration, that means your boss will be more happy about you because you made him save time, and so on, and so on, and so on. And not just because of that, but also because of something psychological called flow. There's this Hungarian psychologist called Mihaly Csikszentmihalyi, which studied why certain people do only a single job during the whole lifetime and not get bored. And the reason is the psychology of flow, meaning that if you find a way to get an activity, even a boring activity, in an entertaining way, you will be satisfied even by simple, stupid operations. And using keyboards are much better than mouse at achieving flow. And I experienced that especially because since I'm mostly a programmer try to get into the flow as soon as possible because it allows them to be more proficient and be less frustrated and be more active. I've noticed, not much in CAD design, but in drawing electronics, that you can achieve kind of the same level of a flow by typing instead of using your mouse. So I really suggest you to, and what does it mean? Not just because you're high on your own hormones inside your blood, but it means that your job is more entertaining, you're less frustrated, you're less bored, and you're also more proud of what you're doing because in the end it becomes much more funny to do. So yes, I totally suggest you use the keyboards as much as possible and learn the hotkeys and the shortkeys as soon as you can. So what else? Well, we've seen few shapes. There are many more, of course. One of the most interesting I just recently discovered is a slot. I tended to do this kind of shape by drawing a rectangle, then drawing an arc, and then or either mirroring it or drawing another arc. Instead, this tool has it all inside of it with just 2 buttons, which is it's amazing for many reasons. Explore them. Don't spend too much time to figure out all of them because you're going to learn them through your designs, through your projects. Another important thing are points. Don't underestimate the power of points because points are going to be useful both as a reference for aligning your shapes, but also for assembly reasons. We're going to see those reasons later. What else we got in here that is interesting? Well, the patterns, for sure. Let's make something less stupid. Something like line. I'm using the keyboard. I have to use the mouse in order to show what I'm doing. I don't use the keyboard. Oh, yes. First of all, I want to show you what are construction features. You know, these are lines. If you draw a rectangle, something like this, then you click Finish Sketch, you're going to get a closed shape. But there are certain times that you might want to make geometries without rendering them on the physical space. And that's the moment where you use construction lines. What it means, if you have this line and select construction, or you can select it even from here somewhere, I don't remember where, you can see this line becomes dotted and orange. And that means that it's not going to be represented on the physical space. And it's really important, especially if you want to make extrusion operations, revolving operations, stuff like that, because it will not be included in the face you're going to select. And this is really useful because otherwise it can be messy quite easily. It's a recipe for disaster. Having not wanted features inside your drawing while extruding, it can be a recipe for disaster. What I wanted to show, however, is that let's make a point in here and make a pattern. Patterns are a way to repeat easily a shape. What it means, if I use, you can see there are two kinds of pattern here. One is circular and one is rectangular. Circular pattern, it's a way to repeat this feature here, this rectangle, over a center point. I select this point, and you can see it's repeated in a circular fashion. I can change the kind of rotation. I can suppress certain elements. I can adjust, where is it? I can adjust in here the number of features. For example, I want 5 of them instead of 3, and that's it. And this is a good way to repeat certain features quite easily. The other way is by using rectangular patterns. This is a bit more sophisticated, but really useful. You select your features. You select the directions. These 2 directions are fine, like these and these. They're already selected by standard. And then you select the quantity for each direction. For example, 3 and 3 is fine. And then I set the distance. Let's say a bit more. I'm showing you this because it's going to be quite relevant later for our projects. No, not 50, sorry. It's wrote. And as you can see, I made a matrix of my features. Well, it could have been better. Oh, come on. More. And that's it. I made a matrix out of a single feature. And this is really useful, again, for many reasons. Well, as of now, I'm just repeating stuff. Later, we're going to see in our project why it's going to be more useful. Just a second. What are the difference between sketches, the three planes? Which one is preferred to choose, and what are the pros and the cons? Known. Well, ciao, Federica. Well, known meaning that known meaning that if you choose one or the other, it's up to your preference. Meaning that I tend to draw something from the bottom up just because I like to do stuff from the bird point of view. But you might want to use different sketch planes for different reasons. Meaning if you have objects that are going to be, I'm going to give you an example. And it's better if I use the circles. For example, I want to make 2 cylinders. Let's totally erase this one. Finish the sketch, then extrude it. I'm going to go fast forward. We're going to get back to extruding much better later. This one extruded by 10. Oh, come on, a bit more. And then I want another cylinder that is going to intersect with the other. Then I have to use a different sketch plane. How do I do so? This one, and then this. Finish sketch, and then extrude it. So I get two cylinders in two different positions. So you should adopt the sketch plane if you, well, first, to start from scratch, choose whatever you prefer. And I usually prefer the top-bottom view. For other reasons, you should use the one which is the better for extruding your object, for extruding your model. Later, we're going to see better the glypho, the object glypho, and I'm going to show you why different sketches are good for certain reasons. Okay, let's remove them, delete them. Finish sketch. So let's get back to here. We've seen patterns, we've seen rectangular sketch, and so on and so on. I'm not going to talk about projecting stuff because it's more advanced and not useful for our purpose. Remember another important feature is the spline lines. If you are designers, engineers, you already know what are spline lines. In here, it's quite easy to make them. You just make points, and then you can adjust them with their anchors. It's kind of easy. It's really, really useful and non-trivial to make them. You get more advanced stuff when you mirror and when you modify. What it means, let's say I have this line. I'm going to use it as a mirror line. So, sorry. So in here, I made this line as a construction line. And now I want to draw something, I don't know, a bit articulated. I don't know, this can be part of a machine, sort of joint or whatever. Join it, and then mirror it. I select all these things as the objects of my mirroring, and then select the mirror line. Using this axis, everything is mirrored. It's more, it's fancy because when you're going to change, the other ones is going to change as well. It's going to mirror it all the time. This is possible because of these fancy symbols that you see in here, these gizmos. These are the constraints. Constraints are the geometrical rules that you apply to your design in order to make it more geometrical. So if you want this line not to be oblique, but always to be vertical, I just say, oh, vertical constraint. And it will always be vertical, even if I later try to change that. There's a magpie out of my window. If I'm going to try to change the position, it's not going to change, as you can see. I can do that again only if I remove this constraint. I do that, and then I can change it again. There are many kind of constraints. The ones that I use the most are coincident, because it makes certain things touching each other. For example, if I want this shape to be coincident to this point, that's it. And tangent. I use tangent all the time because tangent is the way you make stuff look pretty. If I have these three, for example, I have three circles like this. If I just make them touch them, I don't think, let's make it with a different tool. Circle, 3-point circle. As you can see, this is kind of fancy, but not enough, because they intersect and they can be not really good. Instead, if I apply the tangent rules, it's going to make it more appealing in many ways. And if I use this other tool, trim, then I can use these shapes that I obtained. Let's see them if I can. I'm not sure if I can do this. Yes. I can use these shapes that I'm obtaining, which are elegant, which are useful, which are non-trivial in many ways. And equal, it's another really important tool. As I said, whenever you draw something that is not just a line or a spline line, it's nothing more than drawing a set of lines or curve or splines, but with already applied constraints. As you can see, I've just drawn a rectangle, and you can see there are these gizmos that represents the parallel, if I'm not wrong. No, the vertical, the horizontal constraint. At the same time, a square is nothing more than a rectangle with equal sides. Come on, why not working properly? The geometry is over constrained. Okay, let's remove that. Come on, make me happy. Over constrained. Let's pretend it never happened. But I can draw it by hand. As you can see, I made a scruffy shape, and then use the constraints in order to make a regular. Well, it might be interesting to know that as of now, these already are, I don't know what's not working, whatever. It might be interesting to know that as of now, these things that I'm doing are already part of a proper parametric drawing, meaning certain constraints or even setting dimensions. We haven't seen it yet, but it's kind of easy. Sketch dimension is the way that you can identify the dimension of a side, of a feature. And you can leave it untouched or change it if you want. And this already is part of doing parametric CAD drawing at the most lower level. We're going to see much better later why, but it might suffice to say that I can always adjust these parameters, not just from here, but also from another section, which is in here, change parameters. But we're going to see much better that later. Okay, so we've seen enough of sketches. Let's make, I want to make a spline. Because I want to make a sweep operation later. Let's erase these. Let's remove these. It's not useful. Let's remove this. There are other two things useful are trim and offset. I'm not going to touch them now, but you will surely find them useful in your works. I press finish sketch and the sketch is done, wherever it is. Totally vanished. Ah, yes, because it's not shown. Whenever, I'm going to show you it now. These set of operations are the ones that you use to make 3D objects. Extrude is the most simple one. You click onto a surface, onto a shape. It has to be a closed surface, and you can change it, or by dragging the arrow, or by setting here in this dialog, distance 100. There are more stuff that you can change, such as the starting point, the direction, meaning you can make symmetric to sides or whatever, and the extent. Right now, we are just making extent up to a distance, but it's really useful to make different kind of extent. For example, up to all the drawing or whatever, or to a different object touching in front of you. This can be really useful. Taper angle. Taper angle, it's another. It's not. I don't use it a lot, but because I don't, because they don't allow me to play with stuff, because I break the stuff. But the point is, taper angle is the way that you adapt certain surfaces for fabrication processes. When you set up a taper angle, for example, at 3 degrees, you can see it changed the perpendicularity. It's no more 90 degrees, but it's slightly more. And this can be really, really useful, for example, for injection molding. You might know that when you do injection molding, you never extrude perpendicular lines of the mold, because otherwise you will never be able to remove it from your mold. You'll never be able to remove the cast from your mold. So you make a taper angle, usually from 3 to 5 degrees, in order to remove something out of a mold. And this one can be really useful to be set as a parameter. Well, it's in itself a parameter, because every time I change it, it changes something of my drawing. But later we will see how it can be changed in different ways. So we've seen extrude. Let's see revolve. I'm not sure. I'm kind of sure this one it's not going to work. So let me change. Cancel. Change. Edit sketch. Let's make a brand new shape in here. Oh, there's another important thing that is useful for production purposes, which is the fillet operation. we're going to see that later, even for the 3D modeling, but it's also available here for 2D sketching, meaning that you can make tangent curvilinear tangent arcs over the two lines like this, and you can even set the degree of the radius. So finished sketch. I made this new shape. Revolve is another important operation. You select the shape, you select an axis, and you can get really, really non-trivial shapes out of simple sketches. For example, this one is like a spindle. How do they call them? The things that the kids play with. Yeah, the spindle, I think. However, it can be really useful to make circular shapes quite easily, and I totally suggest you to explore it in the best way possible, because as of now, I use most revolving than extruding, because you can make much more interesting shapes out of them. Okay, in here you can see there's also another pattern operations, rectangular pattern, because you can do them even with 3D shapes. Let's make something more. We're going to use them for different reasons. Oh, I don't want to extrude, I want to revolve it. Okay. Okay. Now I want to make a new sketching surface. If you need to, for example, I want to make a sort of pipe going all over this line. And to do that, I cannot use actually, I can figure out ways and strategies and gimmicks in order to make a surface touching this point in a perpendicular way. But the best way to do so is to make a new construct plane and not using the standard ones that are given by the software. I do so from this section, construct. For example, we have plane, where is it? Plane along path. I selected in here, and quite easily I made a sketching plane up to for this line. I press OK, and now I can sketch over it. Well, now you can see why the browser is really useful. I have a lot of things in my environment as of now that can make my operations difficult, meaning that I can get confused by the shapes and so on. In here, I can hide all the stuff by simply clicking the eye icon, and it will be better for me to make the operations. So I want to make a square in here. In here. I finished the sketch, and now I want to make this operation called a sweep, which is nothing more than an extrusion over a line. I select the profile and select also the path. The object you're still trying to create is not visible. Please toggle visibility in your browser. Okay. Here it is. And this is a really non-trivial shape out of a simple one, out of two simple ones. It's the best way to make quasi-organic models. Okay, what else? What else we can see? Well, there are in this modify section, you can find more tools that are really useful to modify your objects. Fusion 360 has this press pull operation that I don't use a lot, and it's a shame because it's really useful to make many operations with a simple click. But I'm not going to explore it because I want you to retain the information I'm giving you today, even for other softwares. And most of the stuff that we've seen as of now are totally feasible in all the other CADs. Well, chamfer and fillet, we have seen fillet, which is the one that makes round shapes over a corner, according to a specific radius. Chamfer kind of do the same thing, but instead of doing a round shape, it kind of flatten it. As you can see, let's make it from a face there, you can see it better. You can see this part is round and this part is flat. And Boolean operations. Boolean operations are arguably one of the most useful and used operations inside CAD softwares because it allows you to create a lot of stuff. There are many operations like shell, like what else? Split body, and so on. That are nothing more than articulated Boolean operations. In Fusion 360, it's called combine. And combine is nothing more than using different shapes, put them together, and make out of two models a single one. For example, I want to use this one and put it below this circular shape. First of all, I have to move it. And I'm going to do so by using this one. This one operation called move copy. Move copy, it's the best way to move something inside Fusion 360. You can move it by hand. Well, it gives you different kind of movement types. Free move is the way you just drag around stuff with your mouse. But I don't use it a lot because it's prone to error. Instead, I prefer to use more geometrical, more mathematical operations such as point-to-point. First, I have to use, yes, this one is fine. This one is fine. And I select the body. Move object selection. Sorry, I made a mistake. Meaning that I have to select the one to which I start the movement. Origin point, here, and here. And you can see, it was placed above it. Once it's placed above, there are still two different objects. Although they are intersecting, they are not the same thing yet. And in fact, you can see from the browser, in the browser list, you can see there is body 4 and body 6. There are two different objects. If I want to make a single one out of them, I just make combine. I select both of them and select the operation. Join is the additive Boolean operation. If I say join, now it's a single component. Okay? In fact, you can see it inside. It's no more intersected because those parts were erased, were eliminated. Instead, and if I click this one, it's going to remove the single object at the same time. It's not just that, meaning that with combine, you can do even different Boolean operation. And cut is the other one. Now it's not going to be a lot, but it's going to be still something. I select the target body, the one with which I want the stuff to be removed, and then select tool bodies, which is the one that I'm going to use to remove. I select OK, and you can see it kind of digging the shape into it. OK, you can understand by yourselves the potential of these kind of operations. But I'm sure most of you already have done that, this kind of operations, either with SolidWorks or Rhino or whatever you use. Don't tell me that you use SketchUp because it's an horrible software. OK. Components. Let's see just components and then move on. Components are the way that you can make assembly. Assemblies are, you have different objects, you want to stick them together, but it's not, how do I say, but there are still two separate objects. It's the way you have for example, you have a furniture, you have a piece of furniture, you have two pieces of wood boards. You want to join them together. You do so by assembling them, and it's the same thing inside Fusion. For example, let's make. I wanted to show you something. Whenever you extrude something, it will erase. It's not going to erase its sketch. It's going to hide its sketch. In order to see it again, you have to select it from the browser list. Okay, let's extrude these two circles. Now I want to put one on the top of each other, not by just moving them, because I wanted, if I were just to move one of them, for example, if I select this one, I say move copy, and then I just move it. Well, I can even, come on, what are you doing? Sorry. I don't know. Ah, yes, because I selected the face, not the object. Yes, now you can see. If I were to move it on the top of it, I might think, okay, now they're together, they will not be separated anymore and whatever. It's not like that, because if I move the one below, it's not going to retain that relationship. Instead, if I do an assembly, for example, I have to convert them, first of all, to convert them to components. I do so new component. And you can see in my browser list, bodies now have become, there are certain bodies that now have become components. Which one is? Well, no one. Let me redo that. New component from bodies and select them. Okay, now these two are components, as you can see. There are no more in the body list. Now I can make assembly out of them. For example, I select, you go in here, joint, and select position on the first component. I select it. I want to choose this point, and the other component, this other point. As you can see, it's going to place one on the top of each other. And now, if I try to move them, they will retain these. Where is it? They will retain this relationship. Come on, are you making a fool of me? Amazing. Try with the other one. It's not even moving anymore. Perhaps it's because the one on the top is fixed and the one above not. However, sorry. Let's move forward, because we are not going to talk about assemblies a lot in our lesson. But consider that it's an important part of CAD softwares. So use them accordingly. Okay, let's move forward. Sketches, we've seen them. We've seen bodies. Sculpt modeling. I'm not going to talk a lot about sculpt modeling because it's not really relevant. You can do parametric modeling with sculpt modeling, but it's more complicated. Sculpt modeling, it's the best way to do direct design, meaning that you can take your shapes, you can easily arrange it, you can easily take a single surface, extrude it, making a new one out of it, make a new one, for example, out of these two, and so on. The results can be amazing, meaning that it's the best way to sculpt really unique, original, and fancy models. And you can totally do parametric design with these kind of things, meaning you can set numbers and formulas and whatever you want. But it's not that easy. You need a clear view of what you're doing. You need a good approach. So I'm not going to talk about it now. Just consider that it exists. It's a huge section inside Fusion 360. And most of you, if you are designers, you're going to use it a lot. It's the same way you use it in Rhinoceros or whatever. Okay. Assembly, we've been talking about assemblies. And feature history. Now let's take a look at feature history. Let me save the form, finish form, okay. As you can see below, this part is now populated. And this is actually our whole design history, meaning every single operation that we did was saved inside of it. And with these player controls, I can navigate through them all. As you can see, everything changes. It's getting back to time. So if I'm back in, and I can also move it as if I'm watching it coming to life. Yes, this is fancy. It's not that useful. But the point is that whenever you travel through your feature history, you can update your stuff. Meaning, if I understand that this sketch, for example, this sketch in here wasn't really good, I want to get back, and I want to change it, I can totally do that. Update it. For example, I want this one to be 500, okay? And I want this one to have an hole inside of it. Then I finish sketch again. I'm still back. We can see the roll bar, the roll bar is still in the behind. If I move to the hand, I can totally see how my sketches changed. Okay. And body comp, remove body comp, warning error. I should check it. Oh yes, perhaps they joined together during an extrusion, which is fine. What I'm doing now is a bit fast forward, meaning that I'm not paying attention to details, to intersections, to many things. Of course, when you do your stuff in a more professional way, you do that with much more care, we do much more attention, with much more focus. And that's what I do whenever I draw something. Now I'm just fast forwarding through all the functionalities. Okay, we've seen this kind of things. Let me see. Exporting. Okay, this is an important part, meaning that once you've drawn something, of course, you want to export it in any way. And in Fusion, you can do that in two ways. You can make, you can do it in many ways, but essentially you want to make a 2D drawing or a 3D export. You can make the 2D drawing out of Fusion 360. It's going to be quite easy. While the 3D export, it's going to require an internet connection because it's a cloud-based, meaning the computation goes over a server. The server make all the computation and send it back to you. Is it because it's too difficult? No. Is it because they want control over your software so you don't use cracked software, or if you don't have paid for it, you can't use it? Yes. But come on, they have to make, I don't know, they have to take the bread to their table, I guess, somehow. So let's understand them in a certain way. I want to show you how to make it quickly, how to make a 2D drawing out of your objects. You do so by changing your workspace. In your drawing from design, you can make, oh yes, I have to save my environment, and then select what I want to take. Let's say I don't want to full components. I want actually just one. Yes, because this is important. Actually, you have to make a component inside the drawing. You can make a body. New component, select body, this one. Okay. You can do it even manually if I'm not wrong. Well, let's make. I'm going to show you appearance and material later. Let's start with the drawing from design. Full assembly, select component. Okay, this one. And I want to create, you can see from this dialog, I selected my component. I didn't want to do the full assembly, just one component. I select create new drawing, template from scratch, it's totally fine. And there are also some standards for technical drawing, units, sheet size, whatever. Not whatever, because they're not relevant. They're not relevant for me now, but they're going to be really relevant if you're going to make technical drawings and the like. And in here you can see I have my technical drawing template, and I can start pushing to hit my recently added object component, sorry. I can choose an appearance, the orientation for start. For example, I want to start with an home view, because I want to see in an orthogonal view my 3D object. And here it is. I can also set the scale differently. For example, if I want one column 5, here it is. I have my technical drawing over I have my objects over my technical drawing. And Fusion 360, well, in general, CAD drawings are really useful for this way, because you can make measures out of them quite easily. You just use this kind of tools, dimension, and drag your figures to have their lengths. You can make even different views. For example, right now, yes, I'm making from a different angle. Or I can edit from in a different way. For example, from here, I can say base view, model appearance, top. Now it took me all the components. I didn't want all the components. However, it's fine. And that's it. For example, I can have projected views of the other sides and so on. And this is really, really cool because in a matter of minutes, you can have a fully understandable technical drawing. Of course, in order to make something more professional, you have to take care, time, adopt whatever are the standards you're going to use, and so on and so on. But even just by doing so and by making an output out of it, meaning saying output PDF or DWG or whatever, I can have a file that I can use, for example, in my vinyl cutter, in my laser cutter, in my CNC, and so on. And this, for me, from the perspective of a digital fabrication professional, it's really, really relevant and important because it's a really, really easy way, speed way to achieve that quite easily. Okay, what else? Let's see also the rendering part. Don't say. I haven't shown you yet that you can apply materials and appearances to your objects. What does it mean? I don't like this one. Let's erase it. Yes. Okay. For example, I want to apply a metal material to this object. I select it. I repeat, I click on appearance. No, I want to start with the physical properties. Actually, I think it got to be a component. Physical material, here it is. It opens up a library of Fusion's, a ready-made library by Fusion 360 with many materials. Oddly enough, there is not a search functionality yet. There is for another feature you're going to see later, but it's not for this one, and I don't understand why. But you can have favorites, you can have your own materials, library, and so on. However, for example, if I want to apply a metal material like aluminum, here it is. I just have to select it and drag it over the object, and that's it. Now this is kind of aluminum. Well, it will have all the aluminum properties of this. This object will have all the properties of an aluminum object, and it's useful, especially if I'm going to make simulations out of it. Let's close, and now let's give it also an appearance. In here, you can see appearance. Actually, I just selected a face, so it's going to make just this face. If I want to make all of it, either I select the component or I make this one, whatever. The important is, if I just select a surface, a single face, I'm going to get a mistake. Appearance, here it is. In this design, yes, you can select the appearance. And in here, we have a library, a search fader. I don't know why. For example, I want a powder coat, like this. The same thing. I just move it and apply it to it. I have to download it first. Just a second. Downloaded it and apply it to it. And there it is. Now my object has the physical properties of an aluminum object and the appearance of a black powder coated object. I can also change the color, if I'm not wrong, meaning that from here, can change the color properties, give it a different hue. Okay, done. This can be really useful in order to have realistic rendering of the things, or to understand better what's going on, or even to get a better view of it all. What I'm going to do now is to make a simple rendering of this object. How do I do so? First of all, I want to hide everything that is not necessary. Even this component, hide it, and just have this one. Have it in here. I go to render, And in here you can see I have these sort of rendering functionalities. I can set up many things regarding both the appearance and the scene setting, like the light orientation, the focal length, the perspective. There are many things you can play with. And honestly, I'm no expert of this topic, but if you're expert of it, you can find all the things necessary in order to make professional renderings. What I want to show you is that I can render in two ways, either in Canvas, meaning with my own computer, or even with the cloud computational capabilities. Let's see the cloud computational capabilities. Let's see this one. In here, I can have certain presettings that will give me amazing renderings of my object. And they can be standard quality, and they're going to be totally free, hopefully, certain. Well, this one, my own version doesn't. I don't know why this computer does. Perhaps I have a different agreement, I don't know. Otherwise, it will require you few credits, meaning money, and some time, of course. But at the same time, I can do a different thing, which is not using the cloud-based computing, but using the local rendering. And come on, this one is totally free, unless you do certain calculations online. I can do that even from here, in Canvas rendering. There are certain settings that I can choose from here and press it. And what it does is iterating many times with ray tracing algorithms in order to give us the rendering of our object. If I get really, really close, it will start again. If I get really, really close and I choose the powder coating, you can see even the powder grain. Well, not yet, because it's still doing basic iterations. Well, you can see it can get to as much as I want. I can even say go infinite until I like it. Otherwise, you can stop. Excellent is more than fine for me. Yes, you can see a certain granularity over the surface. It's because I applied the powder coating, and so it's giving me that feel to the object. It can require some time, especially if you don't have a really performant computer. However, the computer I'm using is really performant, but I have many things open at the same time. So it might require even some time. If it were my laptop, it would have been taken fivefold the time it has taken now to do this thing. Okay, I don't need to go further. Then once I've done, I can capture my image, download it, and that's it. I can have even my rendering done locally. Okay, let's see a different thing. Don't save, I don't care. And the different thing is the export, which is done by here, export. Oh, this is Glyphos, sorry. Let's get back to my project. My dull project in here. Okay, here I am. Let's say I want to export something for a 3D printer. And usually you do so by exporting STL files or OBJ files or stuff like that. And you can do that by here, by 3 export. Actually, if I say so, I don't want to export everything. I just want to export, for example, this one. Let's hide everything else. Oh, no. This one, okay. And also the sketches. Hide them all. Export. Name, stuff. Type. Here it is, OBJ files. OBJ files are recently having an upcomings to STL files, because on OBJ files you can save even the texture over it. While in STL you only have the white boxing. So OBJ files are becoming quite the standard, and I think they will get it. They will become the standard soon. Export. And you can see it's starting a cloud job, meaning they have the data section here, my object, and the status of the operation. It's going to take some time. We're not going to look at it waiting for it. But in few minutes, I will have a message in here, job status, which will tell me your job is done. and that means that that it's been saved inside my computer, and I can simply import it into a 3D printer, whatever. Okay, that's it for the basics. Any questions? Anyone has some curiosity? Anyone want to? Oh, same question. Okay. Anyone want to show something? If you've drawn something with your own computers while at home, is there anyone that wants to show me anything, or there is any question? Amazing. Okay, I'm going to assume that everything is just fine. Actually, we didn't do anything complex as of now. Everything was kind of linear.
Hi,
tell me, Simone.
Just a simple question about selection. There is some tools of selection, so you can ask to the software to select body or face or components, or every time it's just with the...
Well, you can do that from here.
Okay,
from the browser list.
It's not graphic selection.
No, you can do from the browser list, and it's going to be really, really useful, especially when you have large projects with a lot of bodies, a lot of components and sketches and so on. And a good way is also to unselect and select them all at the same time. For example, once you've done sketching, you just need to sculpting or modifying your 3D objects. You do so, you hide all your sketches, and that's it. It's the best way. Otherwise, yes, you just select whatever you want.
Thanks.
You're welcome. Simone, I wanted to tell you something regarding what you asked before. Consider that when you have a large project, not Simone Paganoni, Simone Cacciottella.
Okay. Okay, thanks.
When you have large projects, you tend to divide stuff into groups of components, meaning that inside a single component, you can have many bodies. So you can quickly select a group of objects by selecting its related component. So if you want to select many things at the same time.
Okay. Just because my problem is if I use the square selection, sometimes it takes just some face, sometimes it takes some solid, sometimes it takes a part of components. So
I understand it. Actually, in a create form, you can also make selections by not with the square but with the lines. And it's kind of different because when you have to select faces, it's going to be more useful. And there are certain parts where yes, it's going to be more useful doing one way or the other.
Thank you.
You're welcome. Anna, I can see you're moving your head.
Hi to everybody. Now I was thinking about Rhino, but of course it's different because now I'm using Inventor.
Yeah.
And it's pretty similar to Fusion.
It's the same thing. It's the same thing, meaning that Inventor is embodied inside Fusion 360, but there are a few parametric functionalities that are not inside Fusion 360, but are inside Inventor. However, they're totally the same thing, so it's totally fine. And regarding Rhino, well, Rhino started to deliver inside installer also Grasshopper, which is not the same thing because it's node-based, it's not feature history-based. But I've seen people doing stuff with Grasshopper that it's just mind-boggling, so don't drop it at all. Also, there's another really cool tool. Actually, I've used it just a couple of times because I have a MacBook and it's just for Windows, which is called Monolith. Actually, I don't want to talk about cool software now, but it's really cool. I don't want to forget it. It's called Monolith by Autodesk. It was recently acquired by Autodesk, and I think they're going to include it somehow, somewhere. Project Monolith. It's used to make voxel-based geometries. And it's really, really amazing. And I think it's kind of, I'm not sure if it's just Grasshopper with some fancy interface over it. But it's really cool, especially if you work on the field. Well, if you don't just don't model stuff, but if you want to see also physical properties or making combinations of materials and so on and so on. So Monolith is a really cool software. Okay.
Hi, Antonio. Can I just add one thing?
Sure, Tiziano. Tiziano will give you the
Hello,
lesson.
hello everybody.
And
Just
I am the
recently
fancy.
about,
Sorry, just a little bit introduction. I am the funny guy. Tiziano is the good guy.
yeah, less funny than Antonio.
But it's the good one.
I just wanted to add something because you talked about Inventor Fusion, and
Yeah.
it's some way it's with the lesson I will do about Mesh Mixer. Mesh Mixer has been brought by Autodesk, and it's like an experimental laboratory about mesh that will be integrated in Fusion. So in Fusion, if you switch to mesh design part of the software, you just change the design tab. You will get the basic function about Mesh Mixer. So this is a way we can integrate Mesh Mixer and Fusion work. So what you will do with Alberto in the next lesson and the lesson after, which is mine, we can play with the two different software together. So you can have some mesh that are reference with the same origin and same position with a Fusion file, and you can easily pass the part from the two software. So it's a really interesting way to work. And this is the part which is kind of bit different with Inventor. So Inventor, it's a better tool if you want to go on a really, really parametric part. So the bicycle of Lorenzo was designed in Inventor because there are a lot more function for migrating parameter from one part to the other. And it's a better way to design really complex assembly with a lot of parameters. While Fusion, it's better to make experiment mixing meshes and T-spline was the purple stuff you were playing before, and so on. So it's both of them are really good software that kind of a bit of different target.
I believe that Autodesk is still figuring out what they want to achieve with Fusion. They don't have a clear view yet. Okay, let's get back. Now we get to the hardcore stuff. Parametric with Fusion 360. I'm not going to do anything special, just basic functionalities actually. But again, what these basic functionalities can enable for you, it's amazing. What you can achieve is incredible. And it's a good litmus test to figure out if someone is just sketching stuff over their software or actually they're professional with them. So in order to make some tests, we're going to use the famous Glypho. Enter the Glypho. Glypho is this project by Haz in collaboration with, let me see if I can find some links. Glypho is nothing more than a drawing tool for disabled people that have fine motor impairments. What it means that it will ease their grip over a pen, over a marker, or whatever, and give them ability to draw, to write, and so on. And it's actually cool because it's a good example of how a design can improve one's life. Meaning being independent, even just of drawing or writing something like a note for the groceries or something, can be really, really, really important for someone, of course, for a disabled person. And it can also add some fun to the process, meaning it doesn't have to be a project out of a factory. This one is out of a fab lab, and it's fine that it has these funny colors, it has these funny shapes, it is funny to see, and so on. It doesn't have to be rude. Okay, I'm going to use Glypho for two reasons. First of all, Glypho has many capabilities, many things that will... it's good, many features that make it good to be adapted for a parametric design. And also because I actually have to study it because we have to make a new project. We have to rebrand Glypho, so to say. So I have to prepare an online configurator for Glypho to parameterize it. We are not going to use this model, meaning that designer is designing it from scratch, and making a new version of it, and it's going to be really cool. But for my developer reasons, I have to understand how it's made, so I remodeled it from scratch. We didn't have in our lab a version made for Fusion 360, so I made one yesterday. And actually, initially it was made in SolidWorks, then it was ported to Inventor by Alberto, and now I made it in Fusion. And and actually I didn't fully reinterpreted it, but well, here it is. I didn't set many things yet, but you'll figure out yourself. Well, essentially, most of it is here. Okay, there are certain things that are different, but the most of it is here. So let's talk about parameterization. First of all, and I can't stress this enough, make goddamn sketches of what you want to do. Meaning, I am horrible at sketching. These are my horrible drawings. They look like the footsteps of a chicken. I totally agree with that. But the point is, as it was said at the beginning, when you do feature-based design, parametric design, you carefully have to know what you want to do. You carefully have to understand what are the measures that you want to change and so on. So figure out what you want to achieve. Otherwise, you can easily get to design flows. Like, let's see if I can find it quite easily. This one. This one is part of the glypho. Specifically, it's this part in here. It's the pin part. And now it's properly done. When I was trying to draw it without a clear view, this was a huge mess coming out of it. Okay, so sketch something before drawing. I know you're designers, you're engineers, and whatever you are, you know, I know you already do that, but still do that again, okay? Also, it's a good way for documenting stuff. And documenting stuff, it's also an important part of it. Why is that? Well, you remember at the beginning I told you that being a developer helped me a lot understanding parametric CAD. And the reason is because there are many similarities in the world of programming and the world of parametric CAD. Because in both fields you use variables. In one side they're called parameters, and the other side are called functions, variables, objects, or whatever. And setting properly a software, a code, a piece of code, it's kind of the same job of setting properly parameters for a parametric CAD. Starting from the name you give to the parameters. We're going to see that soon. Okay, let's start. I divided the whole thing in three different topics: direct parameterization, reference parameterization, and formulaic parameterization. I'm going to show you what they mean. And let's start with direct parameterization. It's when you set explicitly, I think there's a typo in there, the dimension or a relationship of a feature. In this way, you will prevent future unwanted changes. Essentially, I set up the dimension of a part, and that will not be changed anymore. Kind of easy, but kind of crucial. And let's start to see what that means inside the glyph that I made. It would have been fun to make it in front of you, but it would have required too much time, so I did it in advance. First of all, I'm going to show you all the things that went through the development of it. So let me play all the video history. We start from the sketches. Oh, too fast. We start from, let me stop it. Start from the sketches. Where are them? Again, we start from the sketches, all the separate parts. Then I got to extrude them all in different ways. Then you can see in here I did something peculiar. I did this thing where I made a sphere. You can see it, placed it in here. Then juxtaposed below this extrusion. And then made a negative Boolean operation in order to have the holding cap for the pen. Then what else we have? Another extrusion somewhere. Here I moved one of the part for the holder. Then I joined them together. And then I made some coloring, some appearances, some physical materials. And then I made the assembly. Okay, and this is the final result. Okay, our glypho. let's start to see how how you set the parameters. I did most of it out of parameterizations. And let's see how to do that within Fusion 360. You do that in this section, change parameters. Well, actually, you remember when I told you that at the beginning, when I told you when you're actually making a sketch and setting a dimension, that is the beginning of a parameterization. And that's true. When you define certain constraints, when you define a direct dimension, that's the beginning of a parameterization process. But you can do that even by here, change parameters. Actually, this is the first thing that I've done. I've started by writing down all these parameters. And because I made the sketch in advance, and after making the sketch in advance, I started sketching with these parameters in my mind. You can see I used a certain way of naming them, which is called underscore spacing. Tiziano uses a different kind of naming, which is called camel case. And I think that one is a bit more professional for his case. But I'm used to, as a programmer, I'm used to underscore spacing, so I stick to that even in here. You can't make parameters with the minus symbol, hold with the underscore if you have to make the space. How you set a parameter? You do that by here. You have head user parameter, you set a name, you set a unit, and then expression. You can also set a comment in case you need anything specific in order to be reminded. And I've done that many times. I've done that so well, even before I start drawing, just so that I was sure that everything would go according to my plans. But you can see in here, there are three sections: favorites, user parameters, and model parameters. You can see in here, there is this section, model parameters. What does it mean? It means that any time that I made an extrusion without declaring a parameter, it actually saved that feature with a parameter on its own. I think I misspoke. Let me explain it better by showing you a sketch. In here, well, you get this fillet in here with a radius of 2 millimeters. I didn't set it. It was automatic. So we can see it's just 2 millimeters. I've done so when I pushed press OK, that is fine. What had happened is that Fusion by itself set up this one, radius diameter D2 by 2 millimeters, and saved it as a parameter inside this section. In this way, if I wanted, I could come in here and change it. Like, let's say I want to say 1 instead of 2. Let's see if I can change it directly. OK, and you can see it changed it directly. And this is the way you do direct parameterization. You define a parameter for a specific feature by declaring it as a variable. Let's change it again. And so it means that every single one of these, it's kind of a parameter. It's kind of a variable that I can simply change. For example, in this part, this is the handle part. I divided it in 2 parts and then joined them together later because it was easier to design them. Sorry. In here, the easiest way, for example, to set the height or the width of this object was to using these 2 parameters. 6, as you can see, the width is 60, but if you look at it, it's holder width because I called the parameter. Quite easy. In here, it's holder length, and that's it. If I were to change the constraints from here, change parameters, I look for it, it was holder width. Set it to 80, for example. As you can see, it changed everything. And since I've drawn it, using constraints, and I made sure that the constraints were solid, meaning that they wouldn't destroy the design after I changed them, everything is changing accordingly. What I mean, it doesn't destroy anything. It means exactly the example I told you about at the beginning, that if you don't set geometries in a proper way, you might destroy something. So have non-closed shapes or overlapping stuff and so on and so on and so on. And I'm sure that there are many, many more features that are not really, really solid in this design as of now. But I tested them before, so I'm going to show you only the ones that I'm sure they're going to work. At the same time, I can set my my parameter with a bit more of articulation, meaning holder length, I can say even holder length minus 10. You can see it changes accordingly, or even by using more parameters. Oh, sorry. On length minus offset. Offset is another parameter that I set, which is actually really small because it's just few millimeters, but it changes everything accordingly. And I use more than one parameter. What you can see, if I change my parameters from here, change parameter. Oh, let's get back again. Here is my design, my final result. Okay, I get at the beginning where I draw on the sketch in the feature history. Where is it? And I want to change this one. Older with, where is it? 280. I say okay. And I finish the sketch. Then I roll back to the beginning. I can see that the whole design updated. So my final object, my final representation changed accordingly. Actually, it said a warning, but I'm going to ignore it totally. But this is actually really, really cool, meaning that you get one single design with many, many results. And this is kind of amazing. I know it's silly or naive from my side, but you just define one single geometry, and it will enable you infinite possibilities. And this is really, really cool. I gotta say something important. That is, if you make a technical drawing of this object, the technical drawing doesn't immediately update according to the parameters you've changed, but you have to re-import a certain object. I'm not going to show you now for time reasons. Perhaps if you have some time later, I'm going to show you. But remember that if you made a technical drawing and then change the parameters, you have to update the technical drawing. It doesn't update that by itself. Don't give it for granted. Okay, let's set the parameter back again to what I had. And actually, this kind of operation, this kind of direct parameterization, I've done that hundreds of times inside my sketches. For example, a sketch in here, you can see there are many, many, many of them that are defined by 3 dimensions. Every time you see fx in here, it means that there is a function behind, and so there is a variable behind, at least a variable behind. Instead, in here, there is no fx, so you can see just 2. And you can see I applied many of them in here, many of them on a side, and then I mirrored it. And as well in here, I had a sketch. Where is it? In here, we're going to see later, it's going to be even more complicated, and for a cool reason, but we're going to show you later. If there are too many gizmos, meaning that if all the constraint symbols just annoy you, you can disable them from display settings, object visibility. You have somewhere, from here, sorry, show constraints, and here, and they're removed. As this part, it shows me all this stuff in here because I mirrored all the things, and that's the result. Every time you mirror, it adds a constraint in here for every single feeder. And that's it. So let's get back to what? To our presentation. Oh, sorry, too fast. And let's move forward. Reference parameterization. You use other parameters to set up relational features, not only for direct manipulation, but also for comparison. Let's try that with the glyphos bar. What it means. Let me see if I can find a page online, which is Fusion 360 parameters, safe words. No, I should check it better. Essentially, there are certain words that you can't use for parameters because they are reserved for formulaic reasons. And I'm going to use some of them soon. Let's get to the bar. Edit sketch. Okay, here. You see this part, this is the slot. Well, this got ruined quite badly. I'm going to see, this is a part where perhaps I didn't check very well what's going on. I didn't set up a feature properly and it got ruined. So this design is kind of flawed. You can see in here, I've set 2 dimensions, but what actually I've done is setting just one of them, meaning that I used a relation between the 2 of them to make them both. You can see that from modify, change parameters. I have this part, it's called bar middle hole side, 3 millimeters. I set just one side in here, bar middle hole side. And this one in here says bar middle hole side times 2.5. It means that instead of having a new parameter, I used the same parameter and added a multiplier to it. Kind of trivial, but it saved me the time to type another parameter. Will this be important? Yes, if I have a large project, can be. Meaning if I have a large project and all the measures are related to each other in a certain way, it's really, really cool to save some time, to save some headaches and so on by finding out which is the least common denominator among these parameters and define them more in the relational way. There are some caveats, of course. There are some problems that can arise, and perhaps this is one of them. Meaning that, yes, I kind of sure that probably it's this bar in here, which I should have set up much better. But the point is that I've done this kind of relationship many times. For example, I've done that even in the, where is it? In the extrusion of my bar. My computer is lagging a bit. In the extrusion of my bar, in here I extruded one time. You can see I extruded with bar thickness. And then I extruded another profile over it. In here there is another line you can see. I don't know if you can see the sketch. But in here there's a sketch below it where there are some lines more. And there is the whole, here it is. You can see there is this offset line, this tab in here. To make this extrusion, I didn't set up a different parameter, but actually I did. Yes, because there's another thing. Oh, sorry. I was actually saying what I wanted to say, but in a different way. I said bar rib, but in a different way, because in here bar rib is set up like this, in a relational way. Where is it? Here it is. I use, instead of simply saying bar thickness times divided by 2, which is what actually I wanted, I added another feature, which is max. Max is another formula inside Fusion 360, which allows to define what values to choose between 2 of them. This means, okay, to set up this measure, choose between 2 values, either 1 millimeter or bar thickness divided by 2. Which one you should choose? The one that is the max. I've set that in this way so that I would be sure that this rib wouldn't be too short in any case. For example, if my bar thickness was, instead of 2 millimeters, was just 1 millimeter, it still would retain 1 millimeter in here. And that's because if I, for example, I were to 3D print this thing, and I divided 1 millimeter by 2, you would get 0.5, which is actually kind of good for a resolution for a 3D printer, but it can become risky. So you don't want to risk your time, to risk your 3D printers, to risk your results. So I use this sort of condition in order to be sure that whatever are the calculation, I always have a safe value. And this is actually kind of common also in programming. But in case I add more values, for example, before that it was 2.5. And you can see it changes to 1.25. If I add more, if, for example, my bar thickness is 4, it will become 2. Okay? So this is a way to make references, but at the same time having conditions. And this is what I mean when I say not only for direct manipulation, but also for comparison. Because before adding my value, I evaluate it and I figure out if it's proper for my dimension or not. Again, this can be really, really useful for production reasons, or even for biometric reasons, meaning you're making a glove for something, you know for sure that your fingers will never be shorter than a certain amount. You can set minus that amount as a minimum for your parameter. Okay. Now let's get back to something more critical. Formulaic parameterization. With a more algorithm-oriented approach, you can coordinate several parameters at the same time, while deciding not only for a feature characterization, but also for its presence on the design. Kind of tricky, but the effect is quite simple. You can see that the glypho here has these features, these holes, this pattern, so to say. And I did that by defining just one single figure, this one, and repeated it all through the bar. Now, if I were to change the length of this part, would the holes overlap? Would the walls, I don't know, be too wide, too small, or whatever? Actually, I did something really neat, which is adapting everything according to a sort of algorithm. And even though Fusion 360 per se is not an algorithm-based generative CAD software, it can allow you for some really cool feature. Let's see how. Okay, what I want to change is bar upper height. Now it's 60 millimeters. If I were to make it shorter, like 40 millimeters, you can see that it got more short and it reduced the number of holes. Kind of cool, is it? Why is that? Why didn't change? Why didn't disappear? And what if I were to make it longer, like 100 millimeters? You can see that now there are more bars behind it. Okay, this is possible. Sorry. This is possible because of how I defined a whole set of parameters. Because in order to get this kind of behaviors, you just cannot, you just don't set a single parameter, but you have to orchestrate several things together to get your result. And I did so with the help of the, where is it? With these ones, bar tab width, bar slot suggestion, bar slot side, bar spacer suggestion, bar spacer, and bar slot number. Yes, you need all of them. First of all, it's bar slot suggestion. Bar slot suggestion is the way I tell it. I want a bar that it's going to be, well, I want the slot of the bar inside to be at least 80 millimeters. Figure out how you can achieve that. And how you can achieve that by modifying the side of a single slot, meaning this part in here. So my bar slot side is defined through this formula, which is kind of long, is min 10 millimeters or bar slot suggestion, okay? Meaning takes at least the suggestion or 10 millimeters. I said 10 millimeters because I didn't want it to destroy everything in case there were too small parameters. So I gave it a minimum amount, which is 10 millimeters, and otherwise it takes the suggestion. Okay, it's kind of easy. Then I have the spacer suggestion. Spacer is the space between the two slots. Okay, and I tell it the spacer suggestion is 2 millimeters, but actually the spacer will be, let's get to it, the max between 0 millimeters and the minus between the bar spacer suggestion and bar spacer slot side. What does it mean? That in here, I don't want the spacer be too small, a negative number, or too large. So, well, actually, first of all, I define it max between 0 millimeters and this whole thing. This is because I didn't want the spacer to be minus than 1. minus than 0, because otherwise it would have destroyed my parameters. Then I choose between the minimum between the bare spacer suggestion and bare slot side, meaning that either follow the suggestion or the slot side, because if the suggestion were too large, I realized that would have been too messy and I wouldn't have liked it too much. So I thought for myself, okay, let's define an extra parameter, make it longer, but make it wise. Then figured out the slot side, the bar spacer, and you can see here in expression you define all the things, but in value you define the actual value. Well, you can see the result of the expression. After defining the bar slot side and after defining the bar spacer, I can calculate the actual number of slots that I want to have. And I do so by taking the whole length of the bar upper height, and divide it by the length of the bar slot side plus the bar spacer. Is it meaningful for you? Meaning is, take this side and divide it by the length of this side plus the length of the spacer. In this way, you get a number, 6. And look at it, the unit column, sorry. In the unit column, I didn't set it as millimeters, because in here, in Fusion, when you set a parameter, you have to define also the unit. Either be a length, a currency, or whatever. There are really many kind of values, but unluckily there are no Boolean values, which is a shame. But also you can define no units, and no units, it's just to define, it's kind of controversial, it's just to define units. So just to define an amount of stuff. And that's what I did in here. Because in here defined, they're going to be a number of 6 features like that, repeated all through the bar. How I achieve that from the geometrical point of view? If I go to the sketch of the bar, should be this one, I did sketch, you can see that I have my feature, the first one that I've drawn, set as bar slot side. Remember, bar slot side is, according to my suggestion, or a minimum size. Then we get in here, no, and that's it. That's it from starting from the sketch. That's nothing more. How it translates in this way? Well, it does so because in here, you can see, there is my standard shape. Then I extruded, oh, come on. I made the whole model, and then I extruded only it. I did so by using the cut option, operation cut. Okay, and you can see in here I also define it not as a length, but as an extent to hole, not as a distance, but as to hole. In this way, it will start from its plane and then goes to the other part. Tiziano actually suggests not to do this way. It suggests to do 2 sides and set both of them up to hole, because in this way you're really sure that you're doing both sides properly. And let's do that for making Tiziano happier. Then in here I did this one, which is a rectangular pattern. Show you. That's it. Rectangular pattern takes a feature, and in my case I selected the extrusion, the cut extrusion, and then set the direction this way, and told it, okay, how many of them should you do that? Well, at least I want one of them, so I set max 1 or bar slot number minus, where is it? I don't know why it doesn't show, but it's -1. -1, here it is. In this way, why I said bar slot number -1? Because I didn't want it to overlap too much to the hand. I show you. Right now it's like this. If I were to write down, to remove the -1, it will become like this. and I don't really like it. Well, I could adjust that with more parameters, but it's so easy to do that with this way. Edit feature, -1. And I also added max 1 because in the case of bar slot number was just 1, if this one was 1, I would have done -1, it would have become 0, but I want at least 1 slot. So I leave it, so with max 1, I'm sure I get at least 1. And for the distance, I set bar spacer plus bar slot side. In this way, it places every new feature according to the distance that I want, meaning the distance, the spacer, and so on and so on and so on. In here I applied minus because actually the direction was intended this way, and if I were to leave it that way, it would have become messy, like this. And this is stupid, so I don't do that. The other direction, I don't need a matrix. I need just one direction, so I leave it to just 1. And otherwise, if I were to say like 4, it would have made more on the other direction. But I don't need them. They would be useless, so I just leave 1. In this way, it creates a matrix of 1 by 5. Okay. Let's see if I change it again. Change parameters. And not change just the length, meaning I can change where is it? This one from here, change it to 40. It gets less slots. But in here, if I say, okay, the slot suggestion should be less, should be like 4. As you can see, not only it made the slots smaller, but it also created more of them. It adapted itself according to the algorithm that I've given to him. And if I were also to add more spacing, like I want 7 millimeters of spacing, because I don't know why, it's going to reduce the number of slots. So kind of tricky to get there, but really, really useful, especially when you have this kind of geometries. And why does the Glypho has this? Glypho has this because it's actually part of the structure. I'm going to show you. Well, actually, now you make me realize I should have done something in order to make it better. But the point there is that the Glypho, let me see if I have it somewhere in here. No, doesn't matter. The point is that this part of the Glypho, this pin, goes inside of it in order to keep the tab in place. I understand where the geometry is disrupting. I have to fix that later. These also are essential to what I'm achieving. Okay, and it might be the case that I have a longer pen, a longer tool. Instead of using a pen, I use a brush, or instead of a brush, I use I don't know, a chisel or whatever. So I might want to have a really longer bar. So I want to adapt it to my new geometry and to my new needs. And this is the way a design really adapts to user needs, really adapts to specific situations, specific conditions, and gets more useful. That's it. It's nothing more than that. And that's it. I think this is with tools like Fusion 360, stuff like this is the most complicated you get without getting into generative design. And generative design, in my opinion, it's a whole set of it's a whole different kind of thing. It's a totally different pot of tea, and that should be interpreted and used in different ways. Okay, final recap. We are getting closer to the ending, so let's make a final recap. What we did parametric design fundamentals. I told you a little bit about the theory behind the CAD design, about parametrization and so on. And I hope it helped you to understand why we do what we do. CAD basics. We've been through sketching, modeling, extruding, revolving, and so on. Again, we use Fusion 360, but these things can be useful for any software that you're going to use. for sure for Inventor, because it's from the same software house. For sure for SolidWorks, because it has a similar philosophy. For sure on Shape, Grasshopper for certain reasons, and so on. Actually, we live in an age where there are countless of softwares for any kind of reasons. And after years of real mess, where anyone who just wanted to do what he wanted to do in his own way, think of softwares like Blender, that for years user interfaces and workflows only useful for itself and not for nothing else. Now we're getting to standardized version of stuff, of workflows and so on. So I hope that the CAD basics that I'm giving you today can be useful even for other softwares. Sorry. And then we made parametric CAD exercises, understanding what are the difference between different approaches. Direct, reference, formulaic. Okay. I'm going to give you a couple of exercises because, well, you are part of a summer course, so you should do them. You should make at least some exercises. And I just want you to make practice with these softwares and with this methodology and with this way of thinking. So I want to test the many features and parameters of GLIFO. I'm going to give you the 3DF file. 3DF is the extension for Fusion. I'm going to give you the GLIFO file, and I want you to test the many features and parameters, find the flaws, and I assure you that there are many, and try to fix them, and then some features of yours. Figure out what are other ways to parameterize it, other ways to customize it, other way to make it more appropriate for a certain need. And if possible, I want you also to design a custom handle to make a device accessible. The world of handles is incredibly sophisticated, but as well at hand's reach for anyone. Pass me the pun, at hand's reach. The point is that designing custom handle can be quite easy. Depends on what device you're going to use on them. I also made for Wiki Factory, there's this, let me see if I can find it. There's this website called Wiki Factory. Crunchbase, why Crunchbase? Where it's a sort of thingiverse for many things. I've set up a couple of tutorials regarding Fusion 360 in order to make one regarding making handles. I'm going to share it with you so you have some indications on how to do that. If possible, yes, I want you to design a custom handle to make a device accessible, specifying what are the user needs. For example, if it's an amputee, or if it's a person with motor impairments, or if it's a person, I don't know, driving under specific conditions and so on. And the interaction involved, like driving, using a toaster, using a pen, using, I don't know, a shaker for making a cocktail or whatever. And if you make them, post them on Slack channel, send them to me or whatever you want, why not? We can print them and figure out how they come out. It would be really, really cool, something really cool to do here at the lab. And then we can make a show reel of all your stuff. Would you like that? I would really like that. Okay, other final recap. What's more to think about? There are many, many more things to think about after this lesson, meaning that it doesn't stop in here. Parameterization doesn't stop in here. There are much more things to talk about. And I want to think about the field you are more interested in. You can even be interested in many fields, not just one. Because each one of them, and I'm sure there are more fields, but I was thinking about them when making this presentation. Each one of these fields gives certain inspiration, certain insights regarding parameterization and model parameterization. Let's start talking about design. Design as a, well, we thought in the recent years, there's a lot of talking about universal design and accessibility. And the reason is what I told you at the beginning, because there are no two people that are the same. Everyone has a different height. Everyone has a different legs length. Everyone has a different radius for the hand and so on. So making something for everyone, it's a challenge that designers should face because of a sort. I think it's the best challenge a designer could face. Design something that could be really, really useful for anyone. Something that is that works even for the macroscopic scale or the microscopic scale. Something that works for a child or for an elder, and so on. And especially the field of accessibility, it's really intriguing, it's really particular, it's really peculiar. And as designers, you should do your best effort in order to make everything accessible. You shouldn't make anti-design, as it's called. Anti-design, it's when you follow certain patterns that instead of enabling, they disable something on an object. In the what's the name of the guy? Don Norman talked about affordance. Anti-design is the opposite of affordances, meaning that they don't enable anymore. In here, in this screenshot, you can see a really cool product made by Microsoft. It's this thing. It's a controller for an adaptive controller for gaming. And it's really cool because you can, well, anyone can play it, even a person with no limbs, even a person with just using the feet or so on. And you can plug into it any kind of device and it will work. And it's an amazing effort from Microsoft in order toward universal design. Microsoft in the recent year made really, really good steps toward universal design and try to give a good examples, giving new guidelines and so on. I really, really suggest you to look after the work. Programming. Well, I assume most of you are not programmers. Perhaps few of you touched programming a few times in their life. However, programming is not scary. Don't worry about it. And there are many ways programming can be useful to make parametric CAD. Essentially, there are three fields: functional representation, algorithmic design, and generative design. That are the best used to make models out of mathematical formulas. In here, in this screenshot, you can see this image got quite famous a couple of years ago because these are objects made by not by a designer but by an artificial intelligence. So this artificial intelligence took into account certain parameters, certain inputs, and devised by several iterations the best way to make this joint. And the first round was this kind of thing. Then it got more alienish, and then became something totally absurd, something totally irrational. But at the same time, this thing, it's more efficient in many ways than this other thing. And this was done, yes, by an AI program, but AI programs are made by humans for the moment being. So if you get into softwares like Wolfram Mathematica or MATLAB or processing or whatever, or Cocopelli, or there are many more, you surely can achieve some amazing stuff just by typing instructions instead of designing. And the results can be amazing. Look out on Google for products made by AI and you'll find amazing results. Engineering. There is a whole field in engineering called multidisciplinary design optimization, meaning that you get into account several disciplines like modeling, calculating, I don't know, the logistics, the expenses, and so on and so on and so on, in order to evaluate the project and make the best out of it. I think, and perhaps this is more my opinion than anything else, that adding the word parametric into engineering can get really into the mood of multidisciplinary design optimization, meaning that if you start to design stuff in a way that gets you to achieve more and test more, it's much better. And well, it opens you many more doors instead of just drawing something once and testing in many ways. It surely is much better drawing something once, having different results, and testing them in many ways according to different disciplines. So if you are engineers, try to understand how to adopt parametric CAD design as an approach to multidisciplinary design optimization. Oh, sorry. Then art. Well, generative art, it's nothing new. It's been around for a while, and it will be for much more. Recently, there's a whole field called data poiesis that entered into as a buzzword for those interested, which means generating art out of data's information. You know, data is some call data the new oil. Actually, perhaps it's going to be the new CO2. And Heart, of course, responded to that by using data in order to make a meaning out of big data. So if you are into Heart, if you are into artistical stuff, look into generative art, look into data poiesis. There are some amazing projects out there and some cool softwares that you can use in order to make art out of parameters. Nothing more than that. Just to a different scale, just to a different level. Can I suggest some software? Well, I would say processing is the best one. Otherwise, you can try to use V4. But I would say for an entry-level, processing is the best one. Sorry. That's it. I want to give you a final consideration, which is a quote from a systemic designer called Daniel Christian Wall. We urgently need an Hippocratic oath for design, technology, and planning. Do no harm. This is really important because you as engineers and designers or whatever you are interested in this topic, you have to take your best effort into make something that gives a benefit to society, your life, your careers, your living, whatever you are. And also thinking about what effect it might cause into the place you live, into your society, into your communities. Daniel Christian Wall say that, meaning that, as you know, the Hippocratic oath is something that doctors does. A doctor, when he becomes a doctor, says, "Okay, I swear that I do no harm, and I will care about all the people in the same way, and I will attend to all of them." I think as designers and engineers, you could do the same. And the approach, the philosophy behind Parametric CAD kind of answers to that. Because if you design something that can be useful in many ways, that can be adapted to many situations, in many conditions, and so on, then you're trying to enable the most out of something for for as many people as possible. So when you do something for as many people as possible, it should give the least harm as possible. Meaning drawing a glyph that will, I don't know, cut the hand of the user, well, it's not a good thing to do. So take into the consideration whatever you do in order to achieve something that Daniel Christian Wall calls as a salutogenic approach. Salutogenic meaning creating a healthy result. I think that's it. Questions, show-offs, comments, something to share, anything? Of course, this doesn't have to be the end of it, meaning we have a Slack channel. Let me see if anyone wrote on it. A direct example of parameterization files, the ones you made, or every time we have invented them. Well, there are, depending the software you use. Meaning that if you use something like OpenSCAD, it's entirely based on parametric modeling, so you find plenty of stuff all around the web. If you look for Fusion 360 examples around the web, I'm quite sure you'll find something. But I gotta say that the best way is to invent something from scratch every single time, because you have to understand what are the relationships underlying your project. When I've drawn glyph from scratch, I could have just copy-pasted the values. Instead, I wanted to understand what's going on in order to make the parameters behave accordingly and not just ruin everything. So yes, you might find something interesting around, and totally depends on the software you're going to use. For example, you'll find plenty of examples in OpenSCAD, although OpenSCAD will require a bit of knowledge in programming. But yes, you might find something. What I was saying is that, would you explain how you have defined the constraints and build the parameters for the glyph? Oh, sorry if you did it, I lost connection for an hour. Oh, thank you. Well, Vale, it's actually a pretty long thing to do. Consider that I'm not sure I've explained it well, but I'm going to give you the files so you can look at all the constraints. And you are going to get the recording of this lesson so you can review that part. And as I was saying, it's not going to be the end of it, meaning that we have this Slack channel that will be open for all the period of the summer school. So use that, talk to me directly, talk to the to the channel for the parametric design, pull to the general channel, talk whatever you want. And if you want, we can talk more also about certain topics, such as how did I understand what constraints to use to make the glypho. The answer is by intuition, nothing more than that. It's the same. Well, I gotta say it's the same as programming. Most of the programming that someone does, it's out of intuition. It's not out of something predefined or rules written in stone somewhere. You have to understand what's going on. So if you look at a specific shape, something like, edit sketch, this one, like this one, I understood that there were two circles overlapping in a certain way up to a certain distance, and there was no one telling me that. I had to understand it. But, well, it comes out of practice, of course. So, to recap, it's not the end of it. We can still have talk on Slack. You're going to get the lesson. If you got more questions directly, you can write directly to me. This is my email. If there are more things you want to share, some examples you did, do that. Use the Slack channel. I want to see it active. It would be amazing to see people sharing stuff and talking about certain topics and so on. Consider that I am, as I said at the beginning, I'm the vanilla guy, meaning that the hardcore guy will come later, which will be Tiziano, Alberto, and Enrico. So, and these hardcore guys are part of the Slack channel, and they can answer certain things that I might not know, or certain topics that are more technical and more difficult. So do get not only my expertise, so to say, but also theirs, which values much, much more. Okay, I think it's it. Thank you for listening to me. Thank you for participating. I'm sure you're going to find you're going to find something more interesting in the next lesson as well. And consider that what I said today applies to many fields, not just for healthcare. The rest of the week will be more about healthcare, and today I talked about many things, not only related to healthcare. This is a good thing, meaning because you can apply these things also to other fields. But if you're here for the healthcare, don't worry, you'll get it. Okay. Okay, thank you again, guys, and hope to hear from you soon, okay?